Everyone, so today we are going to be talking about the system of particles. In physics, the generic term, that is the general term for atoms and molecules making up an object, is referred to as particles. So particles in physics simply means the word atoms and what? Molecules. The collection of two or more particles is often referred to as what we refer to as system of what? Particles. So therefore, if we talk about the center of mass, the center of mass of a system of masses is the point where the system can be balanced in a what? Uniform gravitational field. So the point where the system can be balanced in a system of masses can be referred to as what? Center of mass. The next thing is that there are ways of calculating the center of mass. The center of masses can be calculated depending on the parameters given to us. If we are given the mass and we're also given the distance, if the distance given is the x coordinate, we use the formula m1x1 plus m2x2 all over m1 plus m2. But if the distance given to us is the y coordinate, we use the m1 times y1 plus m2 times y2 all over m1 plus what? M2. We have the rotational and the circular motion. What you have to note about the rotational and circular motion include the angular position. It is something as theta. And we have a formula that connects the distance, s, radius, and the what? Angular position. Then the unit is what? Rad. The unit of angular position is what? Rad. So you have to know that your distance equals to radius times what? Angular position. We also have what's referred to as the angular displacement. That is delta theta, and it is the difference between the delta theta 2 and what? Theta 1. We have the angular velocity omega. The formula for our omega can be what? Theta all over what? Time. That is the angular position over time. The unit for angular velocity, which is omega, is what? Rad per second. We have the angular acceleration, which is alpha. The formula for alpha is equal to omega over t. That is angular velocity over time. And the unit is what? Rad per second square. Rad per second square. We have the frequency. The formula for the frequency is the number of oscillation over time. We have the period. The formula for the period is the time over what? Number of oscillation. So you have to know that the unit of frequency is what? Hertz or per second. And you also have to know that our angular velocity omega can equal to 2 pi f. If the frequency is given, your omega is 2 pi f. But if your period t is given, your omega is what? 2 pi over t. And note, there is a formula relating the linear speed with the angular velocity. That formula is v is equals to what? Omega r. Note, period and frequency, they also have what? Inverse relationship. When we talk about the centripetal force, acceleration and centripetal force. So the acceleration that is directed towards the center is called the centripetal acceleration. While the force toward the center is also called the what? Centripetal force. But we also have what we refer to as the centrifugal force. So the centrifugal force is actually known as the outward force. Outward force. So the centripetal is the inner force, while centrifugal is what? Outward force. The formula for the centripetal acceleration A is v squared over r. If our F is equal to ma, our centripetal force F can equal to what? mv squared over r. Remember that if v is equal to omega r, so remember that we said that v is equal to omega r. So this simply means that whenever I see v here, I will replace it with what? Omega r. So that's what this one does. So F is equal to m omega r all squared over r. So this will now be m omega square r squared over r. R cancel r squared, it remains what? M omega square r. We have the gravitation. Now talking about the gravitation, you have to know that the universal force of attraction between bodies is known as what? Gravitational force. So the universal force of attraction between bodies is called the what? Gravitational force. We have the general formula for the gravitational force. That is F is equal to gm1 m2 over r squared. That simply means that the gravitational force is directly proportional to the product of the masses, but inversely proportional to the square of the distance between the masses. So this F is equal to dm1 m2 over r squared is the formula at the surface, while dm1 m2 over r plus h all squared, that is above the surface. But if it is dm1 m2 over r minus h all squared, that is below the surface. And this F represents the gravitational force, while m1 and m2 are the masses of the bodies. This G is called the gravitational constant, and the value with the unit is 6.67 times 10 minus 11 Newton meter square per kilogram square. That simply means that you have to know the value of this gravitational this gravitational constant offhand in case if you're not given an exam. So you have to also know that we have a relationship between this F and the what? G. So our G, which represents acceleration due to gravity, is equal to Gm over R. That's for at the surface. This is for above the surface. This is for below the surface. And note, this G is called the gravitational field strength. That's it. This small G can be referred to as what? Gravitational field strength. And this capital G is the what? Gravitational constant. And also note, for an orbiting bodies, right there, this angular velocity, the formula is square root Gm over what? Rg. Let's look at some example, guys. The first example we are going to be looking at is that find the center of mass of a system composed of two particles. If the masses of the particles are, this is the first mass, this is the second mass, and their distance, this is the first distance, this is the second distance. So guys, we just write solution. So the center of mass equals the first mass times the distance of the first mass times 1 plus the second mass times the distance of the second mass, 2.5, all over total mass, 2 plus 2.4. So you just bring out your calculator and calculate this with a calculator. 2 times 1 plus 2.4 times 2.5 all over 2 plus 2.4. Then we are going to get 1.812. So the center of mass is what? 1.812. You just multiply the first mass by the first distance plus the second mass by the second distance. If there is another mass, you also multiply by the distance all over the total mass. So that's that. We have a second example here. The question is the Earth orbits the Sun in 365 days. So this simply means the time taken for the Earth to orbit the Sun is what? 365 days. So that means that the period T is equal to 365 days. What is the tangential speed? We are looking for the V. If the average Sun-Earth distance is 1.5, so these are the distance, the radius R, that's 1.5 times 10 raised to the power 11 meters. So before I move on, I have to convert these days. I have to convert these days to second. So this T, these days, 365, these days will be converted to hours. That will be multiplied by 24 hours. So I multiply these 365 days by 24 because I'm converting these days to second. So before I can convert it to second, I firstly convert to hours. So because one day, in one day we have 24 hours. So I will now convert these hours to second. So to convert hours to second, I'm going to multiply by 3,600. So this equals 365 times 24 times 3,600. So that will be 365 times 24 times 3,600. Okay. This gives me 315,36000 seconds. So since I've successfully converted my period from days to second, then I'm going to remember that I'm looking for this V. This V. So V is equals to omega R. Since I'm looking for V and I have R is equals to omega R, I will just have to remember that my omega, if period is given, the formula is 2 pi over T. So therefore my V can then equals to 2 pi R over T because my omega is 2 pi over T, so that is 2 pi R over T. So I will just substitute the value of the R here and the value of the T here to get my final answer for the speed. So my V equals 2 times 2 pi times my R 1.5 times 10 raised to the power 11 all over my T, the period, that is 315,600. So if you bring out a calculator, press your calculator, 2 pi times 1.5 times 10 raised to the power 11 divided by 315,36,000. Then I'm going to get 29885.8 meter per second. We have the next example here, example 3, right solution. A plane makes a complete circular turn in 2 minutes. This complete circular turn in 2 minutes simply means a period. So the period capital T is equal to 2 minutes. I have to convert my minutes to second. That is by multiplying it with 60. That equals to 120 seconds. They said if the speed of the plane, my V, is 170 meter per second, V, calculate the radius. I'm looking for the R, and the centripetal acceleration, I'm looking for the A. Since I have V and I'm looking for R, I just have to remember that my V is equal to omega R. My V is equal to omega R. Since I'm looking for the centripetal acceleration, that simply means my A is also equal to what? V squared over R. So this is why I have to get my V before I can get my what? A. So I have to get my V, but I'm given the period T. Remember that my omega, if period T is given, omega is equal to 2 pi over T. Then my V turns to 2 pi R over T. That's the formula I'm going to use. So therefore, my V is 170, my R is what I'm looking for, my T is 120 seconds. So I can just substitute the parameters. My V, 170 equals 2 pi times R all over my T, 120. So I can cross multiply, that will be 170 times 120 is equals to 2 pi times R. Since I'm looking for R, I can divide by 2 pi, divide by 2 pi. This cancels this, then my R equals to, so press on your calculator, 170 times 120, all divided by 2 pi. Then I'm going to get 3246.6 meter. So my distance is that. So now I have to calculate my A. My A will just be V squared over R. Since my V is given as 170, that is 170 squared, and my R is 3246.8. Then if I solve this, that will be 170 squared over 3246.8. Then this gives me 8.9 Newton per kg, or 8.9 meter per second square. Newton per kg is same thing as what? Meter per second square. Okay, I have an example here. It said find the gravitational field strength. Solution. I'm looking for the gravitational field strength. That simply means I'm looking for my G. 10 kilometers above the surface. This simply means the height is 10 kilometers. That is 10 times 10 raised to the power 3 meter. The radius of the Earth, your R, is 6.37 times 10 raised to the power 6 meter. That's the radius. The mass of the Earth, the mass M, is given as 5.97 times 10 raised to the power 24 kg. These are the parameters given to me in the question. I'm looking for the height. So you have to remember that you have been given some formulas for the acceleration due to gravity or the gravitational field strength. You have given those formulas, right? So the formula for the above the surface, your G, will equals to GM all over R plus H. It remains a parameter that I've not written, that is G. Your G is a constant that you are expected to know offhand. Your G equals 6.67 times 10 raised to the power minus 11 Newton meter squared per kg. So that's that. So substitute all the parameters into D, then my G equals G. 6.67 times 10 raised to the power minus 11. The mass, 5.97 times 10 raised to the power 24. Over R plus H, my R is 6.37 times 10 raised to the power 6 plus my H, that's the height, 10 times 10 raised to the power 3, all squared. There should be square here, please. So press this on your calculator. That is 6.67 times 10 raised to the power minus 11 multiplied by 5.97 times 10 raised to the power 24 over 6.37 times 10 raised to the power 6 plus 10 times 10 raised to the power 3 all squared. So the answer equals 9.8 meter per second squared. So thank you for watching. In our next video we are going to be talking about the impulse, momentum and collision.